All right, so this one's going to start out by asking a little bit different for the x and the y-intercepts of 3x squared plus 5x minus 2. So we do know, oops, that this is going to open upwards. I don't know why I did that. Open up, so concave up. We know the y-intercept will be 0, -2. So I can put 1 point on here. Boom, done. And finding the x-intercepts, we might just want to try to see if we can factor this. 3 can only factor one way. We need to end up with a +5, so I'm going to go +2 and a -1. That's going to give me 6 -1, which gives me that middle number of 5. So since my factored form is that, we have x-intercepts or zeros at let's see, 1/3, right? Because we would say, where is 3x minus 1 equal to 0? And that's going to happen at 1/3 and at -2. So we've got one here, and we've got one at about 1/3, so about here. And obviously our vertex is not the y-intercept, so that's okay. Our vertex is going to be a little bit ugly. Vertex at -b/2a, right? -5 over 2 times 3, so -5/6 is going to be our vertex, and we can plug that in and figure out what y value is. But I didn't ask for that. But we can just kind of estimate, because I don't want to plug it in. But we can still sketch, if I could. I can't. Close enough, right? That's roughly speaking what our graph's going to look like, right? So our x-intercepts 1/3, 0, and -2, 0, and our y-intercept at 0, -2. Done. Okay. This next one, I believe there is something similar to this on the homework. So we're given 3 points here. We actually have, sorry, we're given 2 points. We actually have a third one. But the main thing is our vertex here, right? So since we have the vertex, the way to start with this one is with vertex form, right? A times x minus h quantity squared plus k. Our vertex is at -2, -3. So that means h is -2, k is -3. So we've got x minus -2, so plus, and k is -3. So the only thing we got to figure out is, hey, what is a? And so you have a choice. You can use the provided point, or you can use the other point that we know has to be on the graph from symmetry, which is the y-intercept. And honestly, the numbers are easier with the y-intercept. So we're going to solve for a. Solve for our a value. So we're going to plug in our y for the y-intercept, -1, only one negative needed. We're going to plug in 0 for x. Okay, and we're going to simplify. So I'm going to go ahead and add 3 to both sides. 2. And I've got 2 squared, so this is 4a. So a is 2/4, which of course is 1/2. So now we have our formula, right? Y equals 1/2 x plus 2 quantity squared minus 3. That is a perfectly valid formula for the graph, unless it says standard form, in which case you got to multiply everything out. I think there's one more. Yep, this is the last one. Word problem. We've got a model rocket launched with an initial velocity of 150 feet per second from a height of 40 feet. And the equation, the height of the rocket's been given by this function right here. We really don't need the initial velocity and the height of 40 feet because those pieces of information went into figuring out what the equation should be. We don't have to do that in this class. We are given the equation. So this equation, the -16, tells us it's been reflected over the x-axis, right? We've got a y-intercept of 40. So our rocket's being launched off top of a building or something, and of course it's going to go up, and then it's going to go down. There we go. So what is the time at which the rocket reaches its maximum height, and find the maximum height? Well, where is that going to be? Max height is going to be at the vertex. So this question is really asking you to find the vertex. So what is our h location? What's our x location of the vertex? Negative b over 2a. So negative 150 over 2 times negative 16. So the negatives will cancel, so 150 over 32, which will be something. Oops. Let's see, 150 divided by 32. So about just under 5 seconds, 4.6875. Now, so that is time, so that's just seconds. It's a word problem, you need to have units on the answer, right? And then our max height will be whatever s of 4.6875 is, which I'm going to pull up Algebra and use that because I don't want to plug in, right? So we've got y equals negative 16. Let me get x squared. Oops. And then it was plus 150t. So plus 150x plus 40. All right, so there, I'm going to take all these others off. Where's our graph? Here's our graph. Okay. And so this, it's a rocket. It's going up pretty high there, right? And so that equation is r. All right. So GeoGebra named it r of x. So r of 4.6, I can't remember now, 4.6875. So it is going to go up to about 391.5 feet. Of course, we can verify that by using the extremum with GeoGebra, and it's going to go tell us there's our time, and there's our height. 391.5625. 391.5625, and that is in feet. So there we go. That's all that there is to this. It's not too bad. And that is it for this chapter. See you in class.